Good morning, students. I welcome you all for the another session of this design of RCC structural elements. Now, in the previous case, we have solved the type 1 problems. Now, today let us consider type 2 problems. Okay, so already we know that what is the procedure for solving these type 2 problems. Okay, so let us take the first problem. The problem is like this: determine the area of reinforcement required for a singly reinforced concrete section having breadth of 300 mm and overall depth of 710 mm to support a factored moment of 185 kilonewton meter. Adopt M20 grade concrete and Fe415 grade steel. Effective cover to the reinforcement is 35 mm. So see the changes in the problem. Okay, so the size of the beam is given here 300 mm, B is 300 mm, and overall depth means it is a capital D. Okay, overall depth is given 710 mm, and this beam is to support a factored moment. Now see here, moment is given, and that is factored moment means MU. Okay, factored moment of 185 kilonewton meter. Okay, so this is a second type problem. As soon as if you see, so if there is a moment is given, then this is a type 2 problems. Okay, and adopt M20 grade concrete and Fe415 grade steel. So what you need to find out here is area of reinforcement, that is AST. So as usual, you will going to draw the cross section, that is width of beam. Then overall depth of the beam is given here, capital D. And how to find effective depth? So effective cover is given here. Effective cover will be 35 mm. So see, from the bottom of the beam to the center of reinforcement, it is effective cover 35 mm. So how will calculate effective depth now? Effective depth small d is equal to overall depth, it is capital D, minus effective cover. Okay, so we're going to get 710 minus 35, it is 675 mm will be the effective depth of the beam. Okay, so as usual, the grade of concrete is M20 means FCK will be 20 Newton per mm square, and grade of steel is 415, then FY will be 415 Newton per mm square. And factored moment, or it is also known as ultimate moment of resistance, MU. So factored or ultimate means it is MU. Okay, so MU is equal to 185 kilonewton meter. So what is the area of steel required for this beam section? So now using this moment, so what we are going to do? So first use this ultimate moment of resistance. As you know, ultimate moment of resistance MU is equal to, this formula will be used, 0.87 Fy AST into D into bracket 1 minus Fy upon FCK into AST upon BD. So 185 into 10 to the power of 6. Now see, 185, it is kilonewton meter. Okay, moment is 185 kilonewton meter. Now convert this into Newton mm. Kilonewton to Newton, multiply 10 to the power of 3. Then again meter to millimeter, again multiply 10 to the power of 3. So 185 into 10 to the power of 6, this becomes Newton mm. Okay, then 0.87 Fy 415, area of steel we have to calculate. D, effective depth 675 into bracket 1 minus Fy 415 AST divided by FCK B into D. Substitute all the values except AST. Now we have to simplify this. 185 into 10 to the power of 6. First calculate this quantity, then multiply this quantity into 1. So we are going to get 243.70 into 10 to the power of 3 AST. So this whole quantity multiply by 1. Okay, we will get 243.70 into 10 raised to 3 AST minus again this quantity multiply with this term. Okay, we are going to get 24.8 AST square. This AST will become AST square. So rearrange the terms like this. So I will take this term this side, this becomes plus 24.97 AST square minus again this term minus 243.70 into 10 to the power of 3 AST, then this is plus 185 into 10 to the power of 6 is equal to 0. So observe this equation now. Okay, kindly observe this equation. So it is ax square minus bx plus c. Okay, ax square minus bx plus c, ax square plus bx plus c. So it is in the form of quadratic equation. Okay, so this will be in the form of quadratic equation. See, AST square here, AST is here. Okay, so this will be a quadratic equation in terms of AST. So what is the solution of quadratic equation? Suppose if it is in the form of ax square plus bx plus c is equal to 0, then the solution will be minus b plus or minus square root of b square minus 4ac whole divided by 2a. So this is the solution for quadratic equation, that is minus b plus or minus square root of b square minus 4ac divided by 2a. Now note down the terms here. What is b, what is a, and what is c? So ax square, it is in the form of ax square. So a is what? 24.97. A is plus 24.97. Ax square. Bx, this is bx. Okay, x square, this is x. B ax square plus bx. So what is b now? With sign you have to note down. So b will be minus 243.70 into 10 to the power of 3. This is b, including minus sign. So b is minus 243.70 into 10 to the power of 3. And c will be plus 185 into 10 to the power of 6. Okay, c will be 185 into 10 to the power of 6. So this is a, this term is b, and this term will be c. So in this equation you can substitute a, b, c with sign. Now see here, b minus a and c. So it is in the form of ax square plus bx plus c, and the solution is minus b plus or minus square root of b square minus 4ac whole divided by 2a. So substitute the values. Minus b. So minus, what is the value of b? Is again minus. So minus 243 into 10 to the power of 3 plus or minus, okay, b square. So again b is minus. So this whole square becomes plus. So plus 243.70 into 10 to the power of 3 square, b square, minus 4a, and this is c. So minus b plus or minus square root of b square minus 4ac divided by 2e. So a is 24.97. So solve this equation or find out the value of AST. So after solving this, we are going to get area of steel is equal to 830 mm square. Okay, the steel requirement for this beam will be 830 mm square. Okay, so this is the first problem. So let us take one more problem. Okay, so the problem is like this: design the minimum effective depth required. Okay, try to understand the problem here. Design the minimum effective depth required and area of reinforcement for a rectangular beam having width 300 mm to resist a moment of 150 kilonewton meter. Okay, this is moment using M20 concrete and Fe 415 HOSD bars. So what they have asked, design the minimum effective depth required, means small d. So small d is required here. First effective depth of the beam you have to find out. Okay, and area of reinforcement, this AST. Okay, first you have to find out effective depth of the beam, then we are going to find out the area of steel. So width is given, that is B is equal to 300 mm, and to resist a moment, and just see here this is mentioned only moment, not factored moment, not ultimate moment, just it is a moment. So moment means it is M. Okay, moment means it is M here, 150 kilonewton meter. So M20 grade concrete means FCK is 20, Fy is 415 Newton per mm square. So here it is M. So convert this moment into factored moment or ultimate moment. Mu you have to calculate. So if you know M, calculate Mu, just multiply 1.5. So Mu is equal to, that is factored moment or ultimate moment, is equal to 1.5 into M. So we will get Mu is equal to 225 kilonewton meter. So here first we will find out effective depth. In the previous case B and D are given, but here D is not given. First we will going to find out the D. So how to find this effective depth? So minimum effective depth required. Okay. So now equating factored moment, whatever we have calculated here, factored moment Mu, this will be equated to Mu limit, that is limiting moment of resistance. So equate this Mu is equal to Mu limit. Now what is the Mu is equal to, what is Mu limit? So see the grade of steel is 415. So for Fe 415, what is Mu limit? 0.138 FCK BD square. Okay. So this Mu factored moment is equated to Mu limit. So for Fe 415 grade steel, Mu limit is 0.138 FCK BD square. Equate these two. So Mu is 225, it is kilonewton meter, multiply 10 to the power of 6, it is Newton millimeter, that is equal to 0.138, FCK is 20, B is 300, D is D only. We don't know this, so it is D square. So calculate D square now. So D square is equal to this term divided by this. Okay. So D square is equal to 225 into 10 to the power of 6 divided by 0.138, FCK is 20, B is 300. So from this we are going to get the small d. So take this is D square, D will be square root of this. So D will be 521.28. So depth will be 521.28. So always this will be rounded off to next higher values. So depth cannot be in decimal point. So this should be rounded off to the higher value, next higher value. So I am going to write it as, so depth, effective depth required equal to 530 mm, next higher value 530 mm. So this is the first step. So minimum depth for this beam will be 530 mm. Next, so the second step is we have to find out area of reinforcement required. Okay, that is AST as usual, area of reinforcement required. So AST, that is Mu, that is ultimate moment or factored moment, Mu is equal to, use this formula, 0.87 Fy AST into D into bracket 1 minus Fy upon FCK AST upon BD. So substitute Mu 225 into 10 to the power of 6. So 0.87, 415, AST keep as it is, small d is 530, just now you have calculated, then 1 minus 415 upon 20 into AST divided by B into D, small d effective depth. So again you will going to get the quadratic equation. So it is in the form of 24.97 AST square minus 191.35 into 10 to the power of 3 AST plus 225 into 10 to the power of 6, that is equal to 0. Again this is in the form of AX square plus BX plus C is equal to 0. So again note down the constants. B, so this is B, this is A, B and this is C. So A will be 24.97. A will be 24.97. B, so it is minus. So including minus sign you have to write. So B equal to minus 191.35 and C will be plus 225 into 10 to the power of 6. So substitute, therefore AST is equal to minus B plus or minus square root of B square minus 4AC divided by 2A. So substitute all the values. So here we are going to get the two values, two AST values. One is minus B plus of all these terms. Second is minus B minus this term. So because here plus or minus, once if you have to substitute plus sign, next you have to substitute minus sign. So we are going to get the two values of AST. One is positive value, another is negative AST. So AST will not be negative, any negative, so there is no question of considering that. So the positive reinforcement, that is positive value of reinforcement is plus 1450.35 mm square. So this is the area of steel reinforcement required. So in this problem we have first find out the minimum depth required. So for that, whatever the moment is we have calculated equated to mu limit, find out D. Then in second step, so use the equation to find out the AST, that is mu is equal to this equation. So here substitute all the values except AST. So we are going to get the quadratic equation and find out the solution for this quadratic equation in terms of AST. So we have got AST is equal to 1450.35 mm square. So this is the area of steel requirement. So two problems we have solved, that is type 2 problems. Okay. So here moment is given. Okay. We have calculated the area of reinforcement. So please solve once again these two problems. So we'll come up with some more problems in the next session. Okay. So thank you very much for attending this session. Thank you.